Hey, everybody. Thank you. Thanks for being here tonight. Thanks for hanging around, sticking with me while we were sort of getting prepped. So yeah, thank you, Philippa, for inviting me. Yeah, it's great to be here. My partner in AO Lab is someone you may know, Nikita Pashenkov. So he's my life partner, also business partner. So things are okay. And so yeah, I wanted to talk about sort of the idea of strategic prototyping, which is something that I've come to. And I'll try to go, I'd love to just keep this casual. So please feel free to interrupt me and ask a question or ask for clarification, chime in with thoughts if you want to. I think I graduated with my master's in, I forget, 2000. In 2000, and I think despite what the bio says, which makes things kind of sound pretty cohesive, maybe, I feel like I've had a really kind of go with the flow practice. And so that's kind of what I want to share with you guys in terms of kind of my path, but also in thinking about what a prototype is, I guess, because I've found that that's what I've been doing all this time. So like Philippa mentioned, actually I studied architecture as an undergrad, but then was at the Media Lab, the MIT Media Lab. And so really, so not a computer science degree, I didn't have a formal computer programming training, and so, so I really think of it, this is a pretty old drawing someone did of what he thought a workshop I was doing was, and it was really, I still think of this is the best sort of explanation of the kind of work that I do, which is connecting a bunch of things, like all kinds of things, weird things, to a computer. And so I think when I started out, when I left school, I really thought, I thought that I might be doing sort of interactive installations, maybe, something with, to me, design and technology was something very beautiful, so doing sort of things that look like design, but that were done by technology. And actually found myself, and Nikita as well found himself, we found ourselves being asked to do work more in, again, prototyping. And so I'll show some old work here. This is not totally chronological, but roughly chronological. And I guess I wanted to sort of trace a little bit sort of my understanding of prototyping and sort of the different roles that it plays. So this was probably one of the first, an early project that we did for Sony Design Center. Like it says in the bio, typically a sort of research arm, so a design research group that's looking 5, 10, 20 years in the future. They're not necessarily doing product development. So they're looking for ideas and what's coming down, coming on the horizon to have that inform what the company is doing in general. And so they asked us to do, this is kind of like the physical or the photographic, I guess, version of the diagram that I showed you before. So this is sort of what a lot of our work is. We're kind of hunched over a computer. At least the wires are not, there are wires extending to other things, not just a computer screen. So that's, it's not as novel now, but it's something. We're connecting to the physical world. So this one you kind of see these speakers back here. So this was a kind of concept from Sony Design Center around having a way of automating your interior home, automating a domestic interior. So this was 2005. So this is, obviously pre-internet IoT, pre-everything, it's pre-iPhone, I think. So this is really a long time ago. And it was kind of, in a way, it was sort of already talking about some of this home automation and Internet of Things, connected home. But what I wanted to, so the way that this device works is here's this sort of beautiful interface and a way of, if you imagine a home where you can dynamically change all of these settings, preference, the lighting, the music, the sort of sound quality. What if you had a super elegant interface for how to save your preferences and call them back up? So there are these like really designy cubes, and the project was called Mood Mark. So it's like bookmarking a mood, bookmarking an ambiance. So there's this light here, a kind of robotic lamp that could actuate, so it was on a motor, and then it had this capacitive dimming switch. So everything was interactive, but also sending the data so that it could be saved and recalled later on. What I thought was interesting was, so this is sort of what we built. You can see this was a high fidelity prototype, I would say. So high fidelity in that it looks like what a product would look like. It looks like what the vision is. So it's not, it's not a paper prototype. It's not, and it's really, and in fact, this, the context for this project was to present this idea internally in the company and really get people on board with it, like a vision. So it was about presentation. Here they wanted the prototype, but it was all about a presentation tool. Here's how we can communicate an idea. And I always thought these photographs, professional photographs of the project were so interesting because the enclosures themselves were so high fidelity, again, kind of like perfectly made, everything really resolved. And the photographs are so perfect that to me, it's so high fidelity, it almost, especially in this one, it looks, it looks rendered. It doesn't, to me, it doesn't look, and of course that's not the case when you're with it and you're interacting with it. Then it's real, it behaves. It's really magical to see a big lamp kind of move like that. But I really feel like for me, this project was, again, that idea of a prototype as a presentation tool, a prototype to get someone on board, to seduce someone maybe even, right? You want it to really it's all about feeling amazing and sort of having a little bit of that gloss, that romanticism or that finish that convinces someone. This is another project that we did for the same team a year or two later, and this one was not intended to be a high fidelity prototype. They had high fidelity prototypes, sort of to what a look like. So in real, everything really defined and resolved. They had prototypes. These were functional prototypes. So our prototypes were just meant to test the functionality and whether this was fun to use or not. And the concept in this project, this was called Odo. The concept was consumer electronics for kids would be eco-friendly, eco-conscious. So they're all powered through alternative energy measures. In this case, kinetic power. So there's a crank that you turn that powers the camera. And one of the things that was really great about this project was that it was, it was a little bit, it was sort of quicker, and the way that we prototyped it, and here again is where that strategy comes into play. The way we prototyped it was actually by looking around on Amazon for something that was already a hand crank charged. I think it was like a radio or a flashlight or something like that. And then we, figured out where the power lines were, and then we got a little the smallest at the time, one of the little spy cameras, like a USB, or not even a USB, but just like a small SD card. No, it was a USB camera because you had to plug it in to get the images off of it. So sort of cobbling things together, I think of it as quick and dirty. So a prototype where, again, we're not prototyping the manufacturing method. We're not prototyping even the circuit that you would use. We're just trying to prototype the experience as quick and dirty as we can. And what I really liked about this project is that originally the plan was to have a crank with a battery, and then the camera would run off of the battery. So many, that's how most of our devices are. They have batteries in them. You kind of charge the battery and it runs off the battery. But if you think about the experience, but when we were doing it, we sort of, I think almost even on a whim, we just thought, well, before we figure out the battery charging and everything, why don't we even just see if we can directly power the camera without a battery? And the camera was so low power that we found that, and so, it was connected, you start cranking it and you kind of see the power light turn on, and then you just kind of see if you can keep the power light on, and then you see if you can press the button and take a photo while the power light is on. This is, again, a really super bare bones camera, so there's no viewfinder or anything like that. It's still like a spy camera, the minimal camera. And what was interesting about that is that even though in some ways the functionality is less, because if you stop cranking, the camera is off, you don't take the photo, but in a weird way, because of the context, it sort of made the concept even better, we thought. And in dialogue with the design team playing with this prototype, there was something really nice about, again, that message of being energy conscious, right? Feeling that it was hard to crank. That was something that was really surprising, is you're cranking it and it's hard to keep it going fast enough to power the camera. You're sort of sweating, you hold it a certain way. And again, that's sort of like a minus. That's not necessarily a great user experience as we think of it now. But it fit with the message. And it was this other interesting take. And so for me, this project was the first one that we did where I really started to see prototyping as a part of a design process, not as a communication tool, but as a way to figure out how something should behave. And I don't think that that's so, I don't think that that feels so new now, but I think, again, these are pretty old projects. And I think now with startup culture, the idea of sort of trying to get things working as quickly as possible, it's been nice to see that, that sort of like everybody's caught on to the importance of prototyping. I also wanted to, this is another project that we worked on, a similar kind of forward, like research-oriented design group, this one at Nokia. And this was also a prototype. But this is a prototype of sort of an idea or a thought experiment, if you've heard the term thought experiment, which is kind of think through a kind of weird, the purpose isn't to be practical exactly, it's just sort of to get at some other interesting question. And so this project was about trust, and we were brought in for a workshop to think about all of the issues with trust and the idea of trust specific to phones and devices. And one of the sort of anecdotes that came out in this workshop was the mechanism, I don't know if any of you have gone through, of, you have an alarm clock, you have, a phone with an alarm on it, but you still ask a friend to wake you up for something really important. You're like, hey, just call me tomorrow morning and make sure that I wake up. Or maybe you're traveling with a colleague and you've got a flight the next morning and you're just like, just make sure that I woke up. And so out of this conversation came the impetus to basically design a whole device that would just formalize this idea. So what it is an alarm clock that you set, but it has this little baby alarm clock or satellite in it. So when you set the alarm clock, it also sets this small alarm, and you give the alarm to your friend, and then your friend goes wherever. You don't have to be co-located. And when the time gets there, it goes off for them, and they need to call you. So in a way, this is really ridiculous. Again, it's not supposed to be a product. I hope no one ever makes a product like this, because they're going to lose a lot of money. But what I thought was so cool about this particular client and the context for this was they were like, let's do it. Let's go all the way with this thought experiment. And so they brought us on. They had already brought us on, so they were stuck with us. But we really, thought about a design for this thing as a device. And one of the really nice things is that we made, sort of similar to the Sony one, a very high fidelity prototype. So, it looks really nice. It's all in there. There's no hidden computer somewhere. There's a GSM, card in the baby capsule. So it's not even working on Wi-Fi or something, or RF to do the communication between this sort of base station and the capsule. They're on it. They're truly independent. They truly kind of, communicate over long distances. And so it was just really it's nice to see, I guess, or to think about a prototype, thinking about high or low fidelity prototypes. We often think about low fidelity prototypes for big ideas to get at some of the questions. We don't often think about really high fidelity prototypes for small ideas in some ways, or small moments. And so this was just a really cool project to work on in that sense. Just some other shots. And you saw that photo of me, sort of connected to everything with the wires. Typically, the way that we work and our role is in the implementation. So we're doing the functionality implementation. So we often are not doing the design of the projects, the enclosure design, even the graphic design of icons and stuff like that. We often are not doing. Sometimes we are. Our projects vary, but usually, and for these ones so far, our role is really the technical side and the concepting. So that's the other side of it, is that sometimes, or when I would think of what we were doing, I would sort of feel like, oh, well, we're sort of engineers. We're coming in to make something, but we really, through our practice, have found that we don't really think of ourselves as sort of just engineers, although I certainly wouldn't say that engineering only needs a just in front of it, but we do feel like we're part of the design process. So we feel like, our work is giving insight to what this product does. Sometimes it's about feasibility, sometimes it's about understanding users, right? So, oh yeah, can you see that? I guess it's kind of low contrast. This is maybe a similar, and I'm gonna kind of jump around here. These are motion graphics. So these are kind of generative graphics. I think these were coded in processing. I can't remember. I can't remember what framework they were. They weren't processing. They might have been C++. But they're generative graphics, and these were done in the context of commercials. So there's a commercial. I think this particular one, I was trying to look it up last night actually, and I couldn't track it down because it's from a while ago, from many years ago. I want to say maybe the client was either IBM or Exxon, and it's a commercial about how they're sponsoring education and science. And so they have all these shots of kids in the classroom and stuff. And so my role here was really to create all of these graphics that they could composite in to be like what math is. So I think, what math is. What does math look like? What does science look like? And I always thought, I love, it's ridiculous in some ways, but also really interesting looking back to think about this as a kind of prototype of, of this abstract idea, So, and I feel like in doing this, you sort of can't see here because it's kind of artifacty, but this, there's a kind of a graph paper looking background. And so when you think like, what is math and science? It's like a lot of numbers changing a lot, and a lot of really fine detail because it's sort of complicated but precise. So there's this, there's a lot of interpretation. Obviously, this is real math. So they're kind of rays and lines. Sort of being generated, and calculating these angles and stuff. But it was really, again, to try to make something that just looks like math and science, And so I always thought it was really funny in a weird way that they're meant to look like data visualizations, but they had to be generated kind of without any data. So they're a kind of prototype of what a data visualization should be, and so I just got really fixated on that word prototype and I feel I've been really kind of digging into what I think, and once you start thinking about it, it's like, oh, everything's a prototype for something else. So that's a little bit of the gist of this. This is a more recent project. So everything I showed up to now is, definitely probably 10 years ago, I want to say, or older. This is a more recent project, and this is, here are some renderings and sketches for a concept sculpture. Not the official term is definitely not concept car. It's a concept sculpture for BMW for 2017 CES, the Consumer Electronics Show. And it was their vision for what an interior would look like, the kind of new vehicle interior in this time when we have so much other technology and stuff, right? And so here are the, here are the designs, and then here's the prototype. So this is very high fidelity. It's 1-to-1 size, so this is, the real thing. DesignWorks, the company, which is a BMW company that did this for. They're our client. They do this in-house. So they have huge CNC. They have a CNC room. So again, it's high fidelity. It is about communicating, but it's also sort of, again, in the process, you kind of are figuring out little things. So it tells a story. It's very high fidelity in the surface, in the form, and kind of the build. The physical part is high fidelity. The function is not high fidelity. So it's interactive, but it plays kind of according to a certain script. So kind of, at certain points you can choose something. It's a little bit more like a choose your own adventure. It's not fully functional like some of the previous things were, or like all of the previous things were fully functional. You could really set the lamp to whatever you want and save it and make it they were fully functional. This one is functional, the technology works, but it's sort of half scripted. So it's narrative, I would say. So here's a kind of dashboard, imagining a dash without the sort of analog instrumentation that we know. This is a vehicle that has a lot more autonomy, although you notice there's still a steering wheel. And so there's sort of, this panel here was this holographic touch display. So it was a kind of haptic, ultrasonic, haptic. You see something hovering in the air, a kind of project optical trick that makes it look like there's a small dynamic graphic hovering in the air. And when your hand intersects that plane, you get this sort of ultrasonic vibration. You feel a vibration. So I'll kind of go quickly here, a little bit of what it looks like to prototype. So we have to build, they build this high fidelity in terms of the right dimensions and stuff to test some of these things, to calibrate before it goes in. These tail lights, were something that we were tasked with. Basically all of the technology is up to us to sort of like figure out how to implement so that it looks and feels real. These tail lights are, kind of custom LEDs, but because they're this weird shape that moves, that isn't flat. Yeah. We were, CES is in January. We were working on it. We probably got the project in July or August, but we were working on it from then, but the biggest meat and heart of it was October, November, December, and December was like our holidays were real, it was very intense. We're actually doing CES 2020 for them. So we're already sort of anticipating a similar crunch. And it's not just us, one of the things about working on a prototype like this is, as much as it's kind of a big project for us, it's like, it's complicated, we're dealing with all these things. We're like a drop in the bucket on this project. What it takes to fabricate something at this scale with this level of finish, there were dozens of people working on it, for that same time. And so being a part of that process and seeing, in a weird way, the fabrication really leads, the physical design really leads. That's partly because of, what is the most important part of their brand, honestly. But it's also because it takes a long time to fabricate things, and they need to be perfect, and they need to be fitted, and it all has to be designed before they can start fabricating, right? So in contrast to some technology where you sort of feel like, let me just get the hardware spec'd, and then I can kind of keep on working on the software up until the last minute. You can't do that really in the same way when you're trying to get physically as high fidelity as this. So the tail lights, here's what it looks like sort of in one of their model shops, and here's what it takes to kind of do, there's nothing that fancy. You guys maybe already tried animating LEDs yourselves or whatever. It's not so much that here, it's really the effort on our part, a lot of it is in interfacing with the model, getting it to fit properly, and interfacing with their timeline too, and what it takes to kind of, do these things, and that even a sort of high-tech thing has a lot of low-tech moments where you're just doing things by hand. So a lot of electronics, a lot of hardware is, honestly, it's Nikita doing most of it, soldering. It's a craft. It's manual labor in a way. It's a craft. It's a manual skill, and so just wanted to sort of share that part of it. So these places where, we use the strip, but in the places where you can't do it, we have to have these moments where we manually lay the LEDs there. We were very tired in this moment. So our eyes are open, but inside we're dying, but we're proud. And then it has this amazing moment. So, there's a kind of, it's so surprising every time how much work it takes to get high fidelity. It's like those last 5% of fidelity almost take as much effort as like the first 95% in some ways, And it's the same working on those motion graphics. It's like you get the thing up and running, and then it's like you're tweaking, like changing things by 1 pixel, changing the R value by like 2. You're really in there super fine-tuning, but that's what it takes when you want to get to the sort of level. And I think it's just, again, going back to that term strategic prototyping, the question is, when do you need to be high fidelity, right? So for certain moments, for certain clients, it's a commercial, it's in a movie, or it's of course that high fidelity is expected, you need to be there. But for a lot of other ones, you're exploring an idea, you're trying to get funding more for a business model or something like that, you maybe don't need that high fidelity. And so I think it's worth recognizing how much work it takes to get to that level, and also, again, being strategic about it. So this is our kind of rare internal project. We actually have a lot of internal projects, but they take the back burner a lot. And so this was, also the prototype of an idea in a weird way, or sort of old technology, cassette mixtapes and cassettes. And the idea, sort of all the nice things about cassettes. They're physical, you can trade them. Once you have them, you really have them. You can't lose, you can lose them still because they're physical. Sort of the idea of like making your own labels and kind of curating this thing. Sean, obviously Nikita, yeah. And so just wanted to show a little bit of sort of, initial sketches and wireframes for how things work, but then, really wanting to go high fidelity in the functionality. So being, so we made this, I guess I talked about the cassettes, but the idea is that this is a really small player, but it plays off of SD cards. So, and the idea is maybe you have old, SD cards back when, a 500 meg SD card was like the biggest one, but it's obsolete now. And so you put some MP3s on there. And the idea, so the idea is that you can put MP3s on there, and you can also put animated GIFs. So, and if you name them the same, kind of in the directory structure on the SD card, it'll play them at the same time. So kind of, trying to go a little further than cassettes. But, a lot of this honestly is like, oh, there's an OLED, we like OLED screens. We like the way that OLED screens work, and we want to try something out. And, we want to do something with music or animated GIFs. So, it's coming for these internal projects a lot of times. We try to come up with a concept that includes a lot of things that we're already interested in, and they might not be ideas; they might just be materials, or a certain graphic or something like that. So here's our, mixed up is the name of it. I'm just conscious of time. So maybe I'll cycle through some of these things a little bit quicker because I want to leave enough time for discussion with you all. Does that sound good? Is that okay? So if I'm like cycling really fast and then you see something where you're like, hold on, I need to know more about that, just stop me. A collaboration that I did with an artist named Jessica Rath, building an installation that was trying to simulate, not even simulate is the wrong word because it implies a certain level of fidelity, that it'll match it, but trying to interpret a simulation of what bee vision would be. And so flower patterns, bees sort of have these, their eyes sort of see in all directions, and they really detect sort of edges and motion of color. Not necessarily a kind of high-res 2D image like what gets constructed for us. And so that's partly why you see flowers have these sort of high frequency regular patterns towards the center, is because bees can pick up on that. And so, just a really simple processing program here to kind of imagine each of these cursors is this kind of sensor, like moving these cursors over a photographic image to get this, and we didn't know what it would look like. It was sort of an initial idea, but what was really amazing is this is very simple. So there's nothing smart about this. It's almost like the dumbest thing that you could do, I think. But even when you do this sort of dumb translation of what the bee eye is, and you move it across those parts of the petal, you really see on these lights, you see them start to flash. It looks like a signal, and when it's going over, if it were moving down here, those pixels are kind of all purple. And then as they move here, half of them are white, so you just get this. And so it's, very simple, but just that idea of simulation. A project from, I guess, earlier this year, just interested in GPT-2, which is a sort of a natural language model that was partially released at the time. That was sort of, it was like, you feed it one sentence and it almost can write a whole article. You feed it a sentence about scientists discovered unicorns, and it writes a whole article that sounds super realistic, with like what they eat, all based on this like really huge data set. And so we just sort of wanted to use it. It was actually for a faculty work in progress show at Art Center. And we just wanted to, use it. So we sort of just came up with something, this clock, where at every minute, so every time the minute changes, it will feed GPT-2 with its whatever the time is. So, and then it'll just spit up whatever. And so some of them are, kind of not so readable, and some of them are sort of really uncanny. And so, there are a lot of things here. I don't know if any of you have worked with machine learning or AI or some of these not text generators. But, you really realize how much the human still needs to curate the things that are generated by machine learning. Just a few things. And then, because it was on my first slide, I feel like I have to talk about it. This is a research project that I ran earlier this summer at Art Center. I had a team of graduate students working with me. And I've always been interested in clothes, to be honest. I love clothes, but I love textiles. I like making things. I just like making things. They don't have to be, I don't even want to design them. Sometimes I just want to make them. But at some point, probably 10, 12 years ago, I got really interested in knitting machines for some reason. And so I had all these knitting machines, but knitting and textiles in general are in this renaissance moment right now, where there's a lot of super interesting technology with knitting, with weaving, with different production things, and also different ways of doing the actual fabrication kind of on the fly. And so And so I wanted to make something, create a project that my students could do with me that was centered in a kind of making, but where there wasn't necessarily like a concept already. So it was kind of trying to think through the making. So we just generated a lot of stuff. None of the students had ever knit before. And I had some ideas sprinkling around. I'll go through them really quickly. The first one, fly knit, Nike fly knit shoes to me, or the other knitted shoes, are a real sort of revolution in positioning textiles, this kind of knitting as this high-tech thing, right? And I've been interested in, from a design sense of like, okay, well, how much of that is aesthetic? How much of it is there? And so I just wanted to, I'm trying to play this. Oh, I won't try to play the videos. So we basically just sort of deconstructed these fly knits and tried to replicate them on my old knitting machines from like the 1970s and 80s. This was our first prototype. I thought it was brilliant. This is what the uppers look like when you take them apart. So one of the sort of technological things is that with knitting, you knit these all in one piece. So with stitched shoes, you make them 3D by having all these different pattern pieces, and then people have to sew them together. So one of the sort of, again, high-tech things about knitting is that it streamlines the manufacturing process. So we were knitting these uppers, kind of, it's partly the shape and it's also how they're shaped. So where you see these different insets, there's a certain knitting technique that actually you can replicate on my old machines. So just kind of, trying to do that, and then, what does it mean, I guess, right, is a little bit of my task now, is to frame it, is it about a contrast between the high tech and the low tech, or something about, feminism and when women knit versus when men knit, or the aesthetics of knitting, for sure. You could have a fly knit shoe that had very traditional kind of Fair Isle sweater patterns on it, and it would perform the same way. But they don't do that. They put these kind of high resolution stripes and neon colors and stuff. So sort of a lot of things to interrogate. Trying to recreate the mechanics of the knitting machine. So I'm into mechanical things. Well, I'm not very good at mechanical things. This is sort of a minimal knitting machine that knits a tube. So we made one, and I wanted to make them bigger and bigger. So we sort of made this knitting machine and then this knitting machine. So we knit this, and then we knit this into this, and we knit this into this. What does it mean? I don't know. I just felt like I made the machines. I've got to make this artifact, And it was a lot of manual labor. So, what's the insight from that? It's sort of kind of this concentration of labor, or concentration of work. And then sort of the last thing are these, you saw them on the poster for my talk, using machine learning. So here, we've got a grid of, how many here? 15 patterns. Some of them are are generated by humans. Some of them are generated by machines. Can you tell which ones are which? You can. You can tell. I think you can tell. These ones are, this bottom row is human generated. So I think these are really obvious. These ones are a little bit less obvious, but sort of, using vintage, traditional knitting patterns. We were using kind of image-based neural networks and just generating more patterns and seeing what they looked like. And I could talk about the sort of insights of like what is a pattern, what makes a good pattern, but I thought I'd just show, there is that prototype part of the fly knit. In a way, you could see that machine deconstruction as a kind of prototype. It's a thing that's not the real thing. It's a kind of simulation, if you like. And but what is the goal of the prototype? I think that's all over the place, or it can be all over the place. And so, I just wanted to give you guys a sampling of sort of the different ways that you can work on all of this stuff. And I'll just leave you with this. We do a New Year's card every year. So you sort of see. So, that's it. Thanks, everybody. Comments? Yeah.
What first step have you found most useful when you start a new prototype?
That's a great question. I think it depends on, for client projects, they often, it's like, what is the brief? So for a client project, they often have a pretty constrained brief already. So for us, oftentimes the first step, they kind of know what they want it to be. So for us, oftentimes for a client project, a high fidelity one especially, will be a sort of tech research phase. So we'll say like, yeah, we're pretty sure we can do it. Let's figure out all the technology that we think we need to do it. What platform are we going to use? What kind of machines? Are there sensors? So tech feasibility, I think, is usually our first step to a prototype. That's specific to us because we're creative technologists. So our role is as the technologist. Sometimes the first step to a prototype, and one thing to kind of be upfront about is that I've framed some of these things as prototypes where I might not have thought of them initially as prototypes, right? But it's kind of interesting to think about it as a prototype now. I'd say like the Flyknit shoe, for instance, I didn't think of it, it's close to I didn't feel like I was prototyping the shoe. I felt like I was analyzing it by trying to replicate it. So in that one, it's the analysis that comes first, For something like the Mixed Up, the little MP3 player and animated GIF player, it's that idea. It's just kind of like, what are we doing? We have for once, we have a couple of weeks where we have, we came off a big project. It's like, what's some idea for us? Usually it has to be a really simple idea because it's something that we want to do pretty quickly. We don't know, we're not trying to make a startup with this. So it's a kind of thought experiment in a weird way. So I think you can have many different starting points. Again, for most of our client work, for most of our paid projects, the first thing is technical exploration and feasibility. What's out there? What do you think you can use in what way, right? So sometimes it's like Amazon search. Let me see what's out there that has addressable screens or screens of this size, or can I get LED rings in this diameter? And right now, that tech feasibility is really different from what tech feasibility looked like 15 years ago, because there's so much stuff out there. There's a ton of off-the-shelf stuff. Things are super accessible. So yeah, it's, looking for a library you can use that does some, I know we need to communicate. It's this distance. What's a technology I think I can use? Can I find a library for it on a in a language that I know? It's strategic in the sense of you want to make sure you can do it. You want to make sure you can deliver it before so that you can say, and part of that is to say like, hey, this is actually not going to work, or we don't think we can do this part of it. Let's come up with another strategy for how to convey that part of the experience, right? What if it wasn't LEDs? What if we use a projector instead, right? Something like that. So oftentimes the brief is an idea. It's not necessarily a specific technology to use. I guess that's part of what you can read into this, is that, yeah, we are usually, it's an experience that someone has in mind. So there are a lot of different ways to make that experience feel alive. Yeah.
Since we're so accessible and everything is just
Yeah,
out there,
totally.
What shift did you notice in your area?
It is a lot easier to work with technology, especially the hardware. So when we were doing, those hardware things, there was no Arduino, we're using controllers, coding in C and stuff. It wasn't necessarily that it was harder. There was just less community, less resources. You're not finding source code for stuff. Now, so many things that you want to do, there's like a snippet of code out there. So I think that makes it a lot more accessible, a lot easier. In some ways, it makes it harder too, because it's harder to differentiate,
right? So if you want to do something different from what's out there, that can be a little bit harder. And we've seen our business shift too. Honestly, we used to do a lot of work with consumer electronics companies. So you saw those early projects are Samsung, Nokia. So Samsung, Sony, Nokia. Now we're doing a lot more work with automotive. So we used to be doing work. Now the kind of companies, the part of the business that's at the front edge of technology, they have in-house prototypers now, because now everyone sees the value of prototyping. So that Sony lab is gone, but there's a Sony prototyping lab. Now Sony Design Center Tokyo has an in-house prototyping lab. And so it's just the industry has changed in that way, and that prototyping is not this sort of weird technique anymore. You don't have to convince. It's nice because you don't necessarily have to convince people like, hey, how about you make a fully functional prototype? That used to be very strange, why would we spend that much money to do that? They'd do it for the form, but they wouldn't do it for the function. Now everyone knows you have to do that to vet your ideas. And so I think that's why we see that we're working now more with automotive industry, because it's a little bit, I don't want to say behind exactly, but their timeline is different. They have a lot of again, the physical is in a way so much more constrained. The physical engineering, the mechanical, the fabric, the kind of production, it's a huge thing. Whereas consumer electronics, now they're all about technology. So, they still have a kind of vehicle. So for them, it's less common for them to have although they do also have in-house prototyping and research teams. So that's been a big shift that we've seen for sure.
Do you ever get the opportunity to work? It sounds like a lot of times you get hired as a prototyping in a project. I'm curious what that relationship is with the aggressive team, but also if you ever have to interface. And is that enriching, or is it
Interface with who?
with someone in the team of a client that is already doing some sort of prototyping? When you come in, I guess you get brought in to
Right.
enrich it.
Yeah. And it's not like, oh, they're design teams, especially now they're design teams, they don't know how to do anything. For big projects like CES, it's sort of, they have super technical people, who are great, but they just kind of want the assurance that they need extra maybe, or in this case we did 2017, so they're kind of like, they know they can rely on us, which is really nice, and we really obviously are so grateful for that sort of support and trust. In terms of working with the teams, it usually feels very collaborative. That's where it's most exciting, is when even if it's kind of the design team and we're the technologists, when we're really sharing ideas and thinking what if we worked in this way, and it's not like they're just, what if it, it's about interaction. It's about what the human's doing that's neither completely technical nor completely design. And so that's really nice, I think. And sometimes there are sort of engineering or research teams, but they're not so used to putting something together into an experience. So a lot of it is just sort of understanding what makes a good demo or what makes a good experience for someone viewing it, so that we sort of know, it doesn't have to be, usually it's don't worry, it doesn't have to be perfectly engineered. It just has to work in that moment, in that one moment, to do this one thing, and people won't know. So that's where that strategy comes in too.
Yeah, with all the pain and all the time of doing high fidelity work, what's your thoughts on high fidelity versus low fidelity in, let's say, self-directed or self-initiated projects, be it in art and technology or art and design?
Right. That's a great question. I do think I think it's worth it to go high fidelity. For us, and we do, because we're not so great formal designers. We're kind of it's, for us, it is about a kind of idea of how something behaves. Our independent idea are more about function, a new mechanism. So it's really important usually for us to get very, very high fidelity about that too. Nikita already left, but for him, he nerds out on like he wants to make it small and real, and he doesn't want to have it connected to a computer. You know, and there is a kind of magic to that, like this kind of idea of real. You know, it's different for everybody. I think for sure for us, we feel like when something feels like a product almost, you read it so differently. So that's kind of usually our goal for ourselves, but it's very personal. I certainly wouldn't say in general that I think that's what you should aim for. I think it depends on what you're interested in, but it's also because we think that our strengths are in the implementation in some ways. So because we can do it, because we can make that high fidelity, it's nice to sort of show that off. But we also have a lot of internal things where we're just like, just make it, or like, you know, like the knitting thing. There's tons of stuff that I would like to just knit a sweater, and it doesn't have to be connected to AI. I would just like to knit a sweater and wear it, and like it's a cool looking sweater. So I think there's that part of it too. You know, it's personal. I guess maybe it's partly like what's lacking in the rest of your life. Maybe. I don't know if that answered your question. Yeah.
How did you go from architecture to this?
I've been thinking about it because the MIT Media Lab has been in the news recently for very uncool, lame reasons. And also because I've been thinking about sort of education recently too, and sort of formal training and informal training. I studied architecture at MIT. I was never interested in technology at all. But you know, when you're at MIT, you sort of everyone is in computers out there, everyone's into computers, and so and you know that there's amazing computer science stuff. So I took some computer science classes, and then I had a friend who had an internship at the lab, at the media lab. And he was like, oh, it's so fun to work here. You know, so and then he was like, oh, there's a guy in the group, there's a grad student in the group next door who's like looking for an intern to do some design stuff. And because I was in architecture, he's like, maybe you could do that. He wants you to like design icons or something like that. So I sort of got that, and then this guy changed his research direction. But my advisor and mentor, he was John Maida, I don't know if you guys know him, he was sort of, you know, he was like, we already have you, let me give you some little projects. And so he really, you know, gave me the opportunity to stay on and just sort of like look at what everyone else was doing. And, you know, and then he encouraged me to apply as a grad student. So it was, you know, so when I say I'm a go with the flow person, you know, so like very few things are calculated. I'll sort of like, you know, an opportunity presents itself, like I'll do it, I'll try it. I won't necessarily have like a goal and try to reach that goal. It's just my personality. And I think I've been really, you know, lucky enough, of course, to have opportunities and to stick it out through the times when I had fewer opportunities. You know, I went with that flow too, and I was kind of fine with, you know, really scraping by for a while. So yeah. Yeah.
That sculpture you did for the BMW, is that like, does it actually work?
No. If we look back, it's no. If the wheels, it's just the suggestion, and it's interesting. Oh shoot. What did I do? I quit out of it. Sorry. Anyway, but no, it doesn't move, no engine. That's why they call it a sculpture. In fact, that's why it's really important for them to say that it's not a concept car, because for them, a concept car is they've worked out, and again, think about who they are. Like for them, the idea of what's the interface of the dashboard is like the tiniest detail, like that compared to sort of like the performance of the engine or like how it handles. Traditionally has been so small. Like not that they don't care about it, they care about everything, but if they had to pick one, they're gonna go for the other thing. So yeah, and what was kind of unprecedented about it a little bit is that now that we're starting to hear a lot more about autonomous vehicles and stuff, things like having a brand based on drive, feel of the drive, and performance and quality, like how do you pivot from that, right? And how do you imagine if someone's not driving it, are they going to have that experience? How do you bring that brand, that kind of like, that premium brand and feel? Where do you get to exercise that instead? And it's in how the interior feels, right? It's in what are you doing? What are the activities? So that whole project was about presenting BMW's vision for what an in-car experience would be in a more autonomous vehicle.
How are you figuring out the material use layered with your
Which, like the materials, like the physical materials?
Yeah.
Do you have a certain project in mind?
Like how you go like a little rough with the durability and like the color choice, and then you flip over to like a very polished fabrication.
Right. So that in that case, like for the client projects, they're doing the enclosure design. They're fabricating the enclosure. We're in communication with them about like, here's how big the technology is. We've got to have a space for this. We need this to be wired to this. So that in the high fidelity ones, we have not done the fabrication. So that's all spec'd by them. Of course, a lot of time, the material has an effect on the technology and vice versa. So it's a dialogue, but we're not usually making the decisions. We're helping to inform the decisions sometimes, but it's usually not us doing it.
Does that change your design once they come with you to design of like the approach? And do you ever have to change the technology based on the design?
Yeah, for sure. I mean, it depends on which one comes first and also which one they prioritize, right? So sometimes it's like we want that technology, we want it to behave like that, and we're willing to change the form to accommodate it. Sometimes it's like, no, it's got to look like this, it's got to be this surface, and we've got to find some workaround with the technology. Maybe moving to a totally other technology, maybe changing what the interaction is even, and saying, okay, let's not use gaze tracking, let's do something else because we can't fit it into that package or whatever. One thing I just wanted to add, just because you had asked that question about like whether the wheels move and stuff, I guess it made me think about it as a prototype, right? And I was calling it a high fidelity prototype. Actually, for a car, it's a low fidelity because it doesn't move. The prototype isn't of the car. Actually, the prototype is only of the interior. So the interior is high fidelity. The car still has to look really amazing, but it's a sketch. It's a physicalized sketch. So that in that sense, it's very, and that's why the wheels are just kind of a gesture of it, right? They don't want it to look too detailed. They want it to look high finish, like well made and beautiful, but they don't want you to scrutinize those. They want someone to be like, why does the grill look like this? Or, why is the, where does the exhaust, blah, blah, blah. That's not what it's about. And so to blank that out, again, is a strategy to make it really obvious that they're not trying to prototype the drive performance by making it very visually clear that it doesn't drive. Thank you. Oh yeah, I know it's late.
If we don't have
So.
any more